Whoa, okay. We jamming. Okay, let's see. Hmm.
So exciting. I think it's really sweet. Roma. I mean,
I think also it's our last round. Yeah, except it's not because we're gonna,
Pomodoro.
which we really born. How did you know? The J, it's the turn I, so when it's Monday.
Fingerton I, starting at 1 always, then going up to N.
Not get those. And
And just N, okay.
I will swap you for Nick. I will.
Whoa, okay.
Yeah.
Let's see. Let's begin where we left off here. So the special cases. Again, I think we wrote down the formulas for them right at the end. But let's kind of go over it real quick, and then we'll practice with this because this is what really gets us into 5.1 right here. And I'm recording for the people that are missing today. Let's jam here. So anyway, tell me the formula for starting at 1, going up to N of 1 plus 1 plus 1 plus 1 plus 1 plus 1. How come N?
Because it's 10 times 1.
Essentially, it's N times 1.
One
Perfect. Mm-hmm. Okay. Dum. Then I'm going to go that one right there. We good? So explanation of it, and then the formula for it, because we'll need these here. And we're only going to go up to x cubed here. So the next special case, dun, 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 is this.
NC?
NC, CN, either one. So we have n number of C's added together. Technically, that would be NC. There's the next one. Absolutely.
NC.
There's no U. I'm so sorry. Okay, we're good there. Was that one from last one? Last time? And da 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 da. How about I? Ooh, there's that. Don't remember. I don't remember. Okay.
It's like N times N plus 1 over 2.
Oh,
Sweet. Okay. And this was the one. Let me do it. Yes, this is kind of like the 100. So then we went up to 100. Is that right? Let's do it. Let's do it the abstract method, right? Because we went up to 100. How about if we go up to N? Let's see what happens when we do that. So according to Frederick Gauss, he would have done this if he had the notation. Hey, come on in, coming in. All done. Okay, and you're going now.
I think so.
You're suited up and everything here. That's awesome. Have fun. Okay, so if we would do Gauss's technique over here, right? It would be something like this right here. We would put a second one in here. So n minus 1 plus n, special formula. And we would do a second one. The second one's going to start off with n first. We good? Then it's going to go to n minus 1. And then we just keep on going all the way up till we get to 1. So you guys tell me here. What do we got here now? On the left side, what do we have? What did we just add?
What?
Yeah, on the left side, if I were to add these guys,
Oh.
what do I have here?
So it'd be
What?
N plus 1.
Yeah, how
Plus
fun.
N plus N plus. Sometimes N plus 1.
Uh-huh.
And then.
On the, oh, sorry, on the, yeah, I said it right. On the left side. What did I get on the left side? Still no. What did I get on this side?
Oh, what do you mean? Oh.
On the left side. Yeah, if I added these guys together. Sure.
Two N times sums of that.
Good.
Be
Karis is
two.
good.
Two I or.
N over 2 times N plus 1.
Yeah, it'd just be 2 of these, right? If you adding them up, it'd just be 2 of these guys.
Oh.
So on the left side, I get 2 of these guys. Okay, this one's gonna be a fun one here. So now if I add down, so 1 plus n plus 1. Now what is 2? 2 plus n minus 1. What's that gonna give us? Are we good there? Lila, are we good there? Adding 2 with the n plus 1, you're gonna get an n plus 1 another time. And then we can keep on going. 3 plus n minus 2 would get an n minus 1. And then we keep on going all the way till we get to the end, which would give us right here at the end, n plus 1. Are we good? Sweet. How many of these guys do we have?
N over 2.
Number.
N number of these guys. We good? So technically it would be n times n plus 1, except on the left side we have that little 2. So at this point, we just divide by 2 on all this stuff. Isn't it kind of weird to divide by 2 on like the summation of blah, 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 you know? But there it is, guys. There's a formula. Dun, da, da, da.
Cool.
Okay, the other ones are a little bit more difficult to do, so I'm not going to do those. But we should just, you guys already have the formulas here. Here's n squared. If you were to add n squared up, you'd get that little formula right there. And putting on the board just in case you might have not written down last time, because it was like at the buzzer there. Oof. And the last one here, n cubed. We do n cubed. N cubed is funny. It's this guy right here.
Yes.
Just squared. Now, here we go.
Sense.
It would make sense. How it makes sense.
Doesn't make sense.
But it does make sense somehow. We just don't know how it makes sense yet.
Yeah.
Uh-huh. Cool. Okay, so those are the 1, 2, 3, 1, 2, 3, 4, 5. 5 formulas we get that we need for 5.1. And let's see, I did ask you guys to try your homework, is that right? For Appendix E. Hopefully you guys did try it. And let's go with some of the, ooh, hold on. No, no, no. That's no fun.
Should I this or sweet? No.
Maybe.
Let's see, I'm gonna go like this. I had animations on there. Had to be.
I'll give it to my mom.
Oh,
Sure.
Actually, 29.
no way. Animation up here. Which?
Please leave the one that I got.
Which? Okay. I think we're good now. There it is. Okay, that's what I wanted. Okay, let's go with it here. Let you guys try this. Oh, we're gonna do this here. Let's see. I'm gonna have to. So we're starting at 3. We're going up to n. Are we doing that? Is that right? Interesting.
Just say.
Oh, sorry, just 6. Sorry. And then eventually we're going to go up to n here. So if we were to do this here, we just plug in the 3 each time. Is that right?
Mhm.
Everybody agreed there? We did that last time here, right? So the iteration is we're starting at 3. Bless you. We're going up to 6. So the next one would be 4. 4 minus 2 is 2. And then we get 5. 5 minus 2 is 3. And 6. 6 minus 2 is 4. And then we just get to add all that together, right? We did that last time, right? Just the whole concept of iteration. So 3 plus 8 plus 15 plus 24. I'll let you guys finish that one off. And then think about how you're going to go to 2n.
So. It must fit.
Okay. 50 it is. Okay. So now here's the trick. Here's where we're going to go to. How do we go from 1 to n of 2i? I'll let you guys think about it. I'm going to step out. I'm going to be back.
Maybe citizens too. It's just n plus n. N times n plus 1.
Right.
Okay. Because it's the same as the order, but times 2.
N squared plus n.
2. And it comes okay.
With 4 each classes. Sure.
To the people at home, I'll give you $5 if you mention this to me. Let's see, actually, listen to me.
No, has anyone ever watched these videos?
Anybody with the answer yet? Cool. Talk to me. How'd you guys do it?
The name's yeah.
Okay, constants. That's the rule that we learned the other day. Constant. This little 2 we can actually move in front. No problem. Then we have this little I, and don't we have a formula for I already? Yeah, so we go this. 2 goes in front. Perfecto. It becomes this initially, right? So constants can always be put out in front. And then, yes, we have a formula. We just made that formula. It's n plus 1 over 2. 2's cancel. So we get ourselves that guy there. Are we good? We'll need this very, very much for the next section. We get this? Just kind of getting that little concept of I can change summations into formulas. As long as I'm starting at 1, then I'm going up to n. That's the important part there. Okay, Jam, next one is all yours. Kind of gave an answer on the bottom there, but don't look at the bottom answer in red. Let you guys figure that one out. Go. So, quick thing is, can we split it off by subtraction?
Yes.
Yeah. Well, after we split off with subtraction, can we put the 5 out in front of a summation?
Yes.
Yes.
The other one would just be 2.
It'll be just 2. But then, that's the
2n.
constant formula. Is that right? Yeah. Okay. We're gonna have 2, and we're gonna iterate it n times, right? Cool. I'll let you guys just start it yourself. Go. Okay, we can do it together too. Okay, that's fine too. Yeah, Maddie, go ahead. Okay, he answered your question. Is that right? Or no? Okay, gotcha. Okay, are we good there? Splitting it off by subtraction first. Are we okay there? So first thing is that one right there. Next is we could move the 2 on the outside, and that's fine. We'll just be left with 1. Don't we have a formula for 1 as well? Yeah, we do. Okay, so if we like, we can just put the 2 out in front. And we think of it as a 1 inside there. The 5 gets to go out on the outside as well. Are we okay there so far? You guys talk to me. Just did some pre-algebra stuff. And I think now we can put in the formulas. So 2 is on the outside. What is the summation of I from 1 to n of 1?
2.
No.
I mean, 2n.
When it's that little formula right there. Sorry, guys. I have there. There it is. We good there? And then this little guy is going to be 5 multiplied by.
Plus 1 divided by 2.
Thank you. Okay, then guess what we got to do? We got to do some pre-algebra here. We do have to. Yep, we do's.
It's a really good answer.
I know this is the tediousness is going to happen in 5.1. We're going to have to do all the algebra step by step to get there. So, yeah, I guess so. Common denominators, I guess. Is that right? Let's see if I get. Why did I write that in? Let me just check why I wrote that in. If I got the same answers both ways here, though. I think I got same answers both ways. You guys tell me if I got something wrong. How about that? We'll speed it up into. This is how you do math fast.
Write the notes early and
Yeah,
just
multiply that one, multiply this one. Oh man, are we okay there? What did I just do there?
You multiply out the n plus 1.
I agree.
Okay,
Looks good to me.
okay. Next is common denominators.
Like 2 and
Negative.
2 and 2.
4, okay. 4n is good over here in the front now. Everything else remained the same, right? No changes to the anything else. We good? Anything that we can put together. And the 4n minus the 5n in the back.
Yes.
Sweet. And we got our final answer. There it is. It's negative 5n squared minus n over 2. Are we good? So there it is. That is the summation formula for n of 2 minus 5i, just by doing pieces of it. Yes, that's awesome. We're getting there somewhere. Dun da da da. We're good.
Graphs.
Yes, let's go. Now we're going to connect it to a little graph. What is that little graph all about? Let's go with it here. So I'm going to do this here. I'm going to think about the area of
Just now.
any kind of area. In fact, let's do the abstract form right quick here. When you guys started geometry, if you guys did geometry, you did okay. Can you name me the area of the objects we know formulas for?
Like,
We know the area of
Square.
a square. Okay, cool. We know the area of a circle, rectangle,
Right.
triangle,
Trapezoid.
trapezoid. Whoa, that's splendid. That's awesome.
Yes, if he thinks we know the
An
area
octagon.
rubber duck.
Oh, rubber duck. Cool.
We discussed this.
Cool. Octagon or any n-gon. There was a way you could do it by triangles. I got 6 now.
Cube. Does that count?
Volume. That's volume. So yeah, that's 3-dimensional. So just 2-dimensional. Ooh, yeah, that's the problem. Hold on. So would we know the area from A to B of that? Would we know this area right here that I'm not from geometry?
Sure.
Right? Because you only had 6. Well, let's see. Let's do another one here. Did you guys know? So octagon, pentagon, those are all n-gons, right? How about, did you guys ever take an area of a kite?
He did. He did do that.
Right? Okay. And kite is the same thing as a diamond, right? With the diamond shape.
Rhombus, perchance.
Rhombus, there you go. Funny name.
It's probably almost.
I think that's it. I think there's 8. So, guys, in geometry, we're stuck to those 8 figures. If you could make something out of those, did you guys do an area of an ellipse? I don't know if you guys did area of an ellipse. Yeah, you drew it, right?
We did an algebra 2.
I think we did perimeter.
Okay, perimeter probably would make sense.
I
Uh-huh.
really feel
Like you can do it.
Uh-huh.
Really sure like we did area. I don't know. You can check on the circle, I bet.
Okay, so here it is. We're stuck to 8 or 9 pieces. So if you can make objects out of those 8 or 9 pieces, you're great, right? But once you introduce something like this, which was just
Say
right there, just a curve, and we want the area, I want the area right here. So I want to go into an infinite space, right? Of getting areas. How do I do that? How do I do that with?
the shapes and then add like a little bit to make up space that.
Ooh, interesting. What shapes should we use?
Rectangles.
Right. Are you serious? Maybe we should, huh? Okay.
That's very rectangles to make a curve.
Oh, awesome. Okay. Find the area under the curve this time of f of x. And I'm going to go like this. I'm actually going to name it. I'm going to say x squared. I'm going to go from 0 to 1. That's old.
So
The second picture. Yeah, that's a picture. All right, so let's go. You guys smart people, you okay? We're gonna do rectangles. Okay. Let's see what else we're gonna do.
Less than 1/2,
I think we like.
probably.
You're saying less than 1/2. Okay, the area underneath this curve is less than 1/2.
Yeah, because if you made a straight line.
Perfect. Yeah, so no, it's less than 1/2. Interesting. Okay. Cool.
0.42.
Okay, 4, 2. Any other guesses here?
It's like 0.37.
3, 7. Okay.
I was gonna say 0.43, and then you said 0.42.
Okay. Any other guesses here for the area? I think we should get to the exact area here, just a bit here.
Mm.
Luke,
Okay.
Karis, Lila, any guesses for the area?
2.8.
0.28. Okay.
Feels
Oof. Okay.
it's like
Okay. Luke, Lila,
It's like point.
0.45. Almost a half.
0.40.
0.40. Ooh. Okay. Let's go. Let's go with it here. So we're gonna go like this. And here's a start of something called integral calculus. Let's see what you do. I guess we're gonna do this just for starters. We're good? Let's break this up into 4 different pieces. We're good? And we have ourselves some choice. We have rectangles. We get to say which hand it is. Is it a right hand triangle? Or is it a rectangle? A left? Or we'll actually do midpoint in some way here. So let's do something called the right side. So if I break this up into 4 pieces, I'm going to use the right side of my rectangles to form my end. We good? We can do the left side as well, but we'll see. So I got that one. Then I'm going to go like this. I'm going to go, that is my other right side of my rectangle, right? But I only got to this much. True, true. Then I go here. I only got to this much. And then the last one, because I'm using the right side of my rectangles, I get this right here. So I'm thinking this. If I can get the area of those rectangles, at least I have approximated it. Are we good? Maybe not get to the end, but I approximated. So let's start. Let's start thinking about what I just did with these rectangles here. So if I take 1 divided by 4, that should be 1/4.
Yeah.
This guy would be then 1/2. This guy should be 3/4. And that would be 4/4, but still, we're good. Boom. Okay. And then so I guess we need to figure out what is the width of my rectangles. 0.25. In fact, they're all 0.25. Is that right? If I divided them exactly the same here, that is so cool. Okay, so I got 1/4 or 0.25 here. I got a quarter here. I got a quarter here. So each time when I divide something into pieces, they're going to be all the same exact piece, just to make things good. Next, I'm going to say this. I'm going to say, oh, look at that, some notation here. R is for rectangles. 4 means I used 4 rectangles to do this. And then, oh, sorry, R is for right. Sorry, not for rectangles. R is for the right side. I use my right side of my rectangles, and I made 4 of them. So let's get the area here, at least the approximation for area. 1/4. And then what's the value? 1/4 to the,
1/4 squared.
how come squared, Maddie?
Is that the function?
With X squared.
Because we're at the first rectangle, we went out 1/4, and we're trying to get our height here. So it's going to be width times height. So then notice on the next one, it's still going to be 1/4. Is that true for my width? But what's going to be my height this time?
1/2.
1/4.
1/2 squared.
1/2 squared. How come 1/2 squared?
2/4.
2/4. Yeah, absolutely. We're going to get to the 2/4 in just a bit here. So 1/4. Now we got ourselves 3/4. Absolutely. And then if we really wanted to, we could say 1/4 plus 4/4. Okay, so interesting. So the width stays the same, but the value where we're going to get our height is different. And we actually could enumerate it as 1/4, 2/4, 3/4, 4/4 if we wanted to.
1 fish, 2 fish, right?
Oh, yeah, Dr. Seuss in the house. Okay, your job is to get the area, or at least the approximation area. And this approximation is going to be over or under?
60 times 4 is 60.
It's going to be over because we have the extra space that's above this. All right. Someone got an answer already? Okay, okay.
Same times 4 is
16 times 4. 64, I assume? Yeah.
0.5.
0.5, okay.
So you know.
The answer yet. So I guess I just need an exact answer and then a approximate.
I'm trying to get over 64.
28 over 64?
It's a little less than that. Makes sense. I don't know if I did it right. It was all in my head.
I got something different.
0.47.
Okay.
437. Is that wrong?
Yeah. Let's see. For the exact answer, I think I got 15 over 30. For the exact answer. Oh, you guys just punched in the calculator and just put it in, right? Is that what you guys did? Okay.
Oh, yeah, that's point.
Oh, that makes sense, yeah. Wait.
Is there a review with that answer?
Well, 4 times 4 is 16 times 4 is
Uh-huh.
4. So the first one is 1 over 64 plus 2 times 2 is 4 times 4 is 16 plus 1/16.
Okay.
And then 3 over 4 that I solved that out to be 9/64 if you want.
Minus 6. Okay, let me try it. Let me try it over here then. Let's see. But this is 1/16. So there's 1/64. Everybody agreed with the first one, 1/64. This one is 4, so 1/16. And this one is 9 on top and
16?
16 on the bottom.
Yeah.
And this would be just 1/4.
Is it not 64?
Whoa, sorry. Hold on.
Six.
Oh, it is 64, right? 64? Everybody agreed to 64?
It's
Oh, it is.
it's easier just to factor out ones and fours squared.
Yeah, 64. Okay,
Uh-huh.
yeah.
So I got that right. I just, sometime in the adding, I'm missing this stuff.
Uh-huh. So 1/64. Let's see real quick here. This would be 4 out of 64. And this would be 9 out of 64. And this would be
16,
16 out of 64.
30/64. So it's another two.
30? Is that 30 over here then? 30 to 64? 15 out of 32. All right. I did do it correctly last night. Okay. So we're good. So we know it is 0.468 is a little bit above.
Thank you, Wyatt. Thank you much. Okay. There's the rest of it. Yeah. Gotcha. Okay. Understand. Sweet. Thank you.
The chapter contest.
Yes, I'll grade it this weekend since now everybody
Oh my goodness.
done.
It was like 0.1 on. That's
The thing is, so now we've overestimated it, right? Okay. We have to write this down. I'm going to write this down here. Ready? Just so I know. Maddie, what was yours? Yep. Hold on. Now I'm going all crazy here. 1 second. Where did it go?
I got overestimated.
Right here. I'll put M for Maddie. You got what?
4.2. Or I mean, 4.2.
0.42. Okay. Karis, what did you say?
0.28.
0.28. Okay. Lila?
0.4.
0.40. Is that right? 0.40. Okay. And 0.37. And Luke.
4 5.
Yeah.
0.4. Okay. We will save that. Make sure it's saved. Okay. So we have the overestimated amount, right? So we now know it is less than 0.46. Everybody's still in the ballpark. That's true. So here's what we're going to do next is we're going to do the other way. So that was the right side.
You take the average from something.
Ooh, so now the question is this. If you take the average, is that exact answer? Or is that still an approximations? Shucks. So can we actually get to the exact answer? Oh, sorry, I went too far here. So there it is. There's me breaking things up again into 4 pieces. I'm not sure why the other half is missing here. I'll write it in here just for a little bit. Okay, good. Okay, so we're going to do this here. We're going to take the left side of our rectangles instead of the right side. So there's my dot there. And I'm connecting. Well, hold on. If I'm at 0, 0, what's my rectangle connect? It's like from here to here, is that right? It goes across the x-axis itself. So there's nothing there. Right there. If you want to draw it in, it'll be like this. So this is using left. This is using the left triangles. Ooh, and then at 1/4, I'm going to go up. And that'll be my next one. And I'm going to go up one more. That'll be my next one. And I'm going to go up one more. So now, overestimating or underestimating? It's these little gaps right over here now that are not cool. We've got these little extra gaps right here now. So way underestimating this here. Okay. Still would not be exact. That's the problem. Yeah, we estimated. And then it would be a slight overestimation, right? Just slight. Okay, we're gonna use L for left side. 4, 4. What's the 4, 4 again? What's the 4, 4? How many rectangles we have? Perfecto. Okay. So here it is. I'm gonna go with the width is always the same, isn't it? So boom. And then what's my first value? It is 0 because we're using the left side now. Boom. Okay, next. 1/4 times 1/4 to the second power, I guess, right? Plus 1/2. There's my 2 now. Okay. I can now finally get this guy off. 1/2 to the second power. Is that true? A little tedious, but we're going to get somewhere here. 1/4 again to the 3/4 to the second power. All right. Can you guys give me the estimate here?
Why are we squaring the other one? The 0 and the 1/4 and 1/2.
We're still squaring the 1/4, 1/2, 3/4. Yeah, because that's the position that we have, right? That's the height for our rectangles. Why do we square it? Oh, because because this graph right here is x squared.
Oh.
So if this graph was
So
x
height
cubed, we would be cubing it.
1/2.
Oh, no. Is it 14/64? Because you basically just don't have the last term.
Oh, yeah.
Oh, interesting. Okay. So this one right here, that goes to 0. That goes away. These terms are exactly the same that we did before. Is that right? And then you just don't have that last term of 1/4 plus 1 to the second power. So if we just take off a fourth, as Adrian was saying, that's cool. That's even a faster way of doing it. Seeing the pattern as well. Awesome, awesome. I'm going to go just super fast here. 1/64, 1/16, and 9/64. Was that right? That's what we had last time? Sweet. 1/64 plus 4/64 plus 9/64. Answer is 14/64 and 7/30. 7/32. Anybody on the calculator? What is that about?
0.218.
0.22.
0.219.
19. Okay, 19 or 0.1187 or 1875. That's cool too. Yep. All that's good stuff. Okay, I'll go with Adrian's answer. Okay, everybody's still in the money here for that. That's cool. Okay, guys. Whew.
What was the first one? 0.46.
Anybody? First one was?
0.469.
Whoa, but that's a big spread though, isn't it, guys? It's like 0.47. That's almost half, right? Then you got this one, which is 0.22, which is less than a quarter, right? This is not helping us any.
Chunks.
But yes, they are big chunks. That's the problem. And we have this gaplet in here, like huge gaps in here, right? Boom, boom, boom.
Ultimately triangles.
Okay, we're gonna do one more. We're gonna do one more. We're gonna do one. It is called
Midpoint.
Sorry, it is called the midpoint. So instead of taking the end of a rectangle, not used as much, but just want to show you this is the 3 different ways that we have done these, and you can do the rest of them that way here. So it is the midpoint now. So the midpoint between 1/4 and 1/2 is right here. I go up and I make my little rectangle based upon that. Are we good? That is called the midpoint way.
That and the other one.
Oh, I don't know.
Oh,
Let's
I
see.
I see.
Is this a better estimate?
Yeah,
Is there less? Oh, that's interesting. Because look at this.
it's the outside and the inside.
Yes, the outside and the inside actually will undo each other's air, at least a little bit. That is so cool. Okay. So that one undoes the air of
Okay.
these two are going to undo. Okay. It is. Yeah. I sorry.
How are you doing?
Mostly.
Kinda. So those are the 3 different ways we have learned how to do rectangles. Now the favorite here is going to be the right side. Why? Because midterm does such a better job.
Because it's more difficult to do. Because you have to figure
I
out.
like the left.
Yeah, because you have to do the calculation. Mm-hmm. Oh, hold on. And then also, on the interval, when we start off with, remember how we had like it was 1/4? We start off with 1/4. Then we went to 2/4, 3/4, 4/4. So the iteration actually starts with 1. Interesting. Okay, let's go with the midpoint. Let's see if this one will be kind of close here. So I got M4, what is the midpoint between 0 and 1/4? 1/8.
C4.
Say again, say again.
Should be center.
Centered. Yeah, C4. Too explosive, I think. Okay, I need the exact middle of 1/4 and 1/2.
3/8.
Oh, interesting. Okay, 3/8. Because we technically just broke up 1/4 into pieces, right? So 1/4 was
This is disgusting.
half of that. Oh, I'm so sorry, Adrian.
It's so annoying. I can't.
This is 5/8 now. And then the last one would be 7/8. Okay. Oh boy. Just major big numbers here now. Okay. Can we do it by calculator?
That would be 9 over 25. Right now.
I'll give the answer so we don't have to do all that calculation stuff here.
Oops, there.
Okay, go for it, go for it.
Oh, wait. Four, 2, 4,
0.2, 3 to 8, 1, 2, 5.
256. 256.
I got 21/64. Is that okay?
Same problem.
Same? Oh, okay. So who's closer now? Okay, with the gap, seems like the midpoint does a pretty good job. Maybe it's not exactly there yet, but who's close? Who's the closest?
It should be
Harrison's. Harris.
Karis is the closest.
Yeah.
Karis, what did you have again? Point
0.28.
0.28. No, let's see who else. 3.7. Okay, so 5 away and 4 away. Okay, gotcha. Okay, but hold on, we still haven't got to the exact answer yet, right? We just know it's kind of close to about 0.32-ish because the midpoint helped with the gaps, right? Now let's see if we can actually get to the end here. Let's see. Or leave you on a cliffhanger over the weekend.
It's on the lower end because as the curve grows, like it's making up less than it's growing, so it's losing more. So it's a lower estimate. So I think I'm
Okay, hold on. So let's do this here. Do you guys think it's lower than 0.32 or higher than 0.32812? How come higher?
because you're losing more as the curve goes up than you're gaining back with the.
Interesting. So you're saying right here, right? There's going to be a lesser gap than
Yes.
here, right? Because the curve is going up. There's a tiny bit more area here, right? That you're losing. Interesting, guy. That's so cool. All right. Let's see. Let's see if I have it over here. Let's see if I have the answer. 1 second. I'm going to go this way just for a second here. Do-do-do-doom. Where did we go? Okay. So I'm gonna skip. Yeah, let's do it. Okay, let's go. Okay. Dun 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 dun. Okay, looks abstract at first. We good? But it's gonna make sense here. So we're gonna start off the same thing. So between right side, left side, and midpoint. Initially, midpoint gives us a good indicator for it, right? I mean, you actually can do all three, but which one is the one that started with the iteration of 1 and then 2 and then 3 and then 4?
Right.
It was the right side, is that right? Because each time when you start off, you're starting off with the 1/4 already, right? So let's do this here. We're going to start off. We're going to break this up into a whole bunch of different pieces. We're good?
Mhm.
But we're using the right-hand side. And I just want to see, just maybe, we might get to some kind of answer. Cool. All right, let's go with it here. So, and then this guy's going to be 1. Is that right? We're going to break this up into n pieces. Oh, crazy. Okay. So this would be right n. All right. So, what's the width of each rectangle? 1/n. Are we okay there? Might have got it right away here. So 1/n. We break it up. We're going to go from A to B. Next is if we do this. Sheesh. Okay, so hold on. Let's see if this makes sense here. The time that I'm going to do the first value for it is going to be 1/n. Are we okay there? Does this make sense? So here's where we put our thinking caps on just for a little bit. Let's see, what is it? This is going to be the width of the next rectangle is 1 over n. And then what is the value of the next rectangle? 2 over n. Are we good? Yeah, so we're just going up by 2's squared, is that right? Plus, anybody?
1 over n.
1 over n. Thank you, 3 over n squared. And why are we squaring again?
Because it's for the function.
As the function ourselves is x squared. Okay, cool. And then we're going to keep on doing this for a long time, not forever, for a long time until we get to 1 over n and n over n squared. Cool. Okay, now we got it. Okay, this is cool. This is awesome. So what do we do now? I think what I do is I think about 1 over n is multiplying. I can pull this out, is that right? Is multiplying. Oh, let's see if this makes sense, guys. That's going to be the crazy one. What do you guys say? Agreed or disagreed? Right, so the 1 over n got pulled out because it was already a multiplier. 1 over n squared is in each of those terms, right? And then we technically are just saying 1 squared plus 2 squared plus 3 squared plus 4 squared all the way down. That is so cool. Hold on. Do we have a formula for 1 squared plus 2 squared plus 3 squared plus 4 squared all the way to n squared? Anybody give me that formula?
It is.
It was the I squared formula.
Who has 1 over 6?
Yes, Lila. Awesome. Perfecto. Okay, so we got that formula now. Whew. This is so cool. 1 over n. So I'm going to do this. I'm going to do 1 over n squared, these two right here. Put that together as 1 over n cubed. And Lila gave us the formula for I squared, technically. That is so good. Okay, and then we have to simplify this stuff out. Okay, what do we got here? What do we got here? Oh, how about the n cubed and the first n on top? Can those be canceled off at least a little bit? So that n over there. So I got myself this. The reason is because n cubed and n, I canceled one of those initially already. I got this. Then I go, well, hold on, not yet, not yet. What? How many rectangles do we want? No, we don't want n.
Number.
We want an infinite amount of rectangles because when you make an infinite amount of rectangles, it will lose that gap. The gap should be gone. Are we good? So here it is. I'm going to go and
You guys should get
I got it. I got it. That's fun.
Great thing. I know it's the 4x1 team made it up. I was not in on it until recently.
Okay, so I need to know this here because we know limits because we're cool with limits here. What happens with this guy as n goes to infinity?
As just cancels out.
Ooh, okay, so if the power is the same, then what we do is we just take the coefficients of the highest powers. Perfect. Okay, so then we technically you could do this. You could divide by n squared. That would be the kind of like the proper math way of doing it right here. And this is the long way though. So then you get this, and then you get limit as n goes to infinity of that right there. Hold on, but we got to think about, did we get all the gaps in or not? We got a number. Isn't that kind of crazy? We got a number out of this. And the answer is 1/3. So what does that mean? Area under the curve, right? If we make an infinite amount of rectangles only looking at the right side. Now the only question is this. Is this overestimating? Is it underestimating still? It could be overestimating still, right? Because remember, the right side overestimates.
I think it's not.
Which one was the one that underestimated? Oh, the left side definitely underestimated, right? So hold on. We got to do one more with time remaining. We're going to do this the left side as well. We got to do it the left side.
We have time to like do it all.
Yeah, absolutely. Let's go with it here. So we're going to go this way, except now we're going to go from the left side each time. There are n rectangles. True, true.
Mm.
ln. What is the width of each and every single rectangle?
The
1 over n. What do we start off with?
0.
Oh, we started with 0 first way through. Yeah, okay, so we're going to use everything but the last term. Now, our formula, here's our thing. I don't like the left side because our formula is going to have to be changed. Are we good? Because we have to go from 0 to n minus 1, not from 1 to n.
Just subtract. Great.
We're going to subtract 1 from each of those n's that we have. We good? Is that okay?
Yeah.
Okay, so 6 minutes remaining. Let's go for it here. So tell me if you guys agree. I'm going to pull out 1 over n. So that goes away pretty much. So I'm really just adding from, oh, hold on. I'm starting at 1, but I'm only going to n minus 1. Technically, that's what I'm doing. Right? Still starting at 1 because that's a 0. Why calculate that anyways? So if I wanted to, I could say I'm starting at 1, but I'm not going to n. I'm just going to n minus 1. I'm going to 1 before it. Okay. So 1 over n is good. 1 over n squared is pulled out. Is that right? What are the leftovers? 1 squared plus 2 squared plus 3 squared all the way up to n minus 1. Okay, so that's our little problem. Hold on. So let's go back to our iteration over here. The sum formula from I equals 1 to n of I squared was originally n. Sorry, Lila, say it again. Is it n minus 1? That was n plus 1.
N plus 1.
N plus one.
N plus 1.
Plus
2
times n
plus one.
plus 1.
Uh-huh. Okay.
Okay.
So now what we got to do over 6. That's right, 6. We got to do is we got to change this formula up a little bit here. We got to change it to going to up to n minus 1. So we're going to change it up so that it's 1 less. Now we have to create a whole new formula. Come on.
You just subtract 1 from every n.
Subtract 1 from every one. So n minus 1 is here. Oh, that's interesting. N minus 1 plus 1? That's n. Oh, this one's a toughie. Hold on. This is going to be 2 n minus 1 and then a plus 1. What is that going to give us?
200.
We're going to get a 2n minus 1 this time. Still over 6. Okay, are we good there? We're going to use that formula. We had to create another little formula because we went to n minus 1. Okay, so using this formula now, can you guys do the rest of the work there? Because I'm going to give you guys 4 minutes. All yours. So can you plug in that formula in for this? And then do a little bit of pre-algebra. Are we okay there, though? Or just it's Friday, so like, why do the work? Why do the work, Mr. G? But I know you're going to do it anyways. Oh, in your head. Okay, that's right. Adrian's doing it in his head. Okay, I'll give you guys like, what, 30 seconds? 30 seconds to start here. Okay, here. It was the same. What? It goes to 1/3?
Yeah.
Okay, let's go for it here. So 1 over n squared makes 1 over, so this is just explanation, blah, 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 blah. There's our formula. We good? Cool. We had an n minus 1, is that right? And okay, so I just switched this around. So it's n minus 1 then. How funny. It just switched all the signs. That's all it did, right?
Mhm.
Okay. So 1 over n cubed, is that good? Multiplied by n minus 1, and 2n minus 1 over 6. And what can we do with the n cubed and the n? It's canceled. Okay, cool. So then the nice formula is n over 1, 2n over 1 over 6n squared. Now what do we do?
Top, appreciate it.
No. Now, the now thing. What are we gonna do now?
Set it to.
Multiply it out.
The thing. What's the thing? What's the no?
I'm multiplying each side by 2.
The way we got 1/3, but backwards.
Divided by the highest power, divided by 2.
Yeah.
Wait,
And
you have to
30
multiply it out to do the highest one.
But why did we do that in the first place? Something we did before.
Limits.
The limit. Okay, cool. We gotta go limit as n goes to infinity. We're gonna make an infinite amount of triangles or rectangles. And now we can do this here. We're gonna multiply this all out over 6n squared. And then again, you could just divide out the 6n squared each time. You technically divide out the n squared each time. We got a limit as this, all that good stuff here. All right. And then I guess when we do these a little bit later on, yeah. So divide out the highest power n on top and bottom. Essentially, that's what we're doing. So on top, we get ourselves a 2. This guy here, where does that guy gonna go? 0. This one. 0. This one.
6.
6. Okay. So there's that. And then we get ourselves. Whoa, crazy. Okay. So hold on. We overestimated it. We took the infinite amount of rectangles, we made it a third. We underestimated. We took an infinite amount of rectangles, and when we got it a third, what do we know? It's a third because there's no more gaps, right? So going to infinity takes it to a third. Now, who won? Adrian won. Adrian won. Awesome. Is it true? So 0.33333333.
Wait, 37?
0.37 versus 0.28. Adrian, congrats. We gotta do that. Da, 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 da. That is so cool. Okay, guys, but that is 9.1. Oh, sorry, 5.1. That is the beginning of something called integral calculus. Of course, we're going to have a lot more fun with this.
So sure wheels about where you have to like add C. Yeah, let's see.
Say again.
Then,
Didn't we already do that?
No,
That's
we
just
already did
okay,
that. We did that.
oh, wait, chill then. I didn't think about that.
Okay, so taking something to an infinite amount of rectangles gives us the exact value and eliminates gaps. Okay, guys, we are done for the day.
Try
Have a good rainy weekend and stuff like that. We good?
some
Any games this weekend?
meat false.
No meat for you guys, so huh?